Let's have a look at our exponential function. There's the basic curve, y equals a to the power of x, where the base is bigger than 1. If the base is in between 0 and 1, then we would get the blue one there. And of course we don't have bases that are negative, and we don't have base 1 either, because base 1 would just be the horizontal line. The domain, as we can see, is all real x. The range is y is greater than 0. There's no symmetry about it, so it's not an odd function, it's not an even function. Back when we did curve sketching, you might recall what happens when we look at y equals function negative x. And that, of course, reflects in the y-axis. So in fact, these same graphs I could write a different way. The red one could be a to the power of negative x, where the base is in between 0 and 1, because it would be the blue curve reflected in the y-axis. And the blue one could be written as y equals a to the power of negative x, where the base is greater than 1, because it would be the red curve reflected in the y-axis. Then it's inverse, the log function. Okay, well, if it's the inverse, the domain and range swaps around. So we know that for a log function, the domain will be x is greater than 0, and the range will be all real y. It'll be a reflection in the line y equals x, and it would look something like that. But that would be the one where the base is greater than 1. And there's the one, the blue one is the base in between 0 and 1. That would be the log curve. So if I wanted to draw y equals the log of 3x, well, I could rewrite that using my log laws. Log 3 plus log x. So using our curve sketching ideas we saw, I know, well, the basic curve is y equals log x. What have I done to it? Well, I'm shifting it up log 3 units, so it will go higher. The x-intercept would actually equal 1/3 for that one. What about 2 to the power of x plus 3? Well, the basic curve, 2 to the power of x. But in this case, because it's grouped with the x, it's going to be a horizontal shift. And we've shifted it left 3 units. So if we move that over 3, and the y-intercept becomes 8. What about the log of the absolute value of x? So the basic curve is y equals log x. Now what did absolute value x do? That reflected in the y-axis. So we'd end up with something like that. So ends our look at exponentials and logs. That was a quick little topic, wasn't it?